This new section is entitled The Area of Kites. The first thing we need to do is go over the one and only theorem in this section. Now, remember what a kite is. You start off with a common base, and then you build an isosceles triangle. Those two sides are equal. And then beneath it, you draw another isosceles triangle. They don't need to be congruent, but nonetheless, we drew another one. Okay. It turns out that the diagonal, the long diagonal, and this shorter diagonal, they meet at right angles. In fact, let's label the endpoints of the diagonal. AB is one diagonal, and CD is the other diagonal. And the theorem just states that the area of this kite is 1/2 the product of the diagonals. 1/2 AB times the length of CD. The proof is straightforward. Let us call this point E. So we have a top triangle, ABC, and we have a bottom triangle, ABD. And the sum of those two areas, the sum of the areas of these two triangles, is the area of the whole kite. So the proof. The area of the kite is equal to the area of the top triangle, ABC, plus the area of the low triangle, ABD. Now, the area of the top triangle is 1/2 times the base, which is AB. And since this is a right angle, that's the height. 1/2 the base times the height. The height is CE. Plus the area of the lower triangle. The lower triangle is 1/2 times the base, which I'm going to use AB again. This is the base, and that's the height. I can use this as the height only because it meets what I defined as the base at a right angle. So it's 1/2 the base, which is AB, times the height, which is ED. In these two terms, I can factor out what's common. 1/2 AB. 1/2 AB. And what wasn't in common goes inside the brackets, namely CE plus ED. But what is CE plus ED? Well, CE is this, and ED is that, and when you add them together, everything else stays the same, but when you add these two together, you just get the line segment CD. But that's exactly what I said the area would be. Is 1/2 times one diagonal times the other diagonal. You multiply the two diagonals, you divide it by 2, boom, you have the area. Okay, it's really as simple as that. Just multiply the two diagonals, divide that product by 2, and you are done. You now have the area. Okay, so we'll work out some problems. Suppose you have this kite like this. where this is 6, and from here to here is 26. Well, the area of the kite, that is how much area is in here. And we'll assume that we are in inches. So the area is one diagonal times the other diagonal divided by 2. 2 goes into 26 13 times. 6 times 13, 78. Inch times inch is inch squared. There's 78 square inches in this kite. Oh, I need to convince you they're a kite by doing this. Now it's a kite. 2 isosceles triangles with a common base. That's a kite. There's lots of ways of giving the information. These two are equal, and these two are equal. And I don't tell you how long that diagonal is. In fact, that one is 14 centimeters. And let's see what I can get away with giving you. Say 20 and 20. And when I say 14, I mean the whole thing. Okay. So what that tells me is that each of these are 7. Each of these are 7. And I guess I have to give you this length. Call it 8. Okay. So we have this big triangle, the right hand one. It's 14 and 20. But it's isosceles. This is also 20. That is, when I cut it in half, I get, when I draw this line at a right angle, it cut it into 2 equal triangles, 2 congruent triangles. So this is 7. Now, I can figure out how long that is. For the moment, call it x. 7 squared plus x squared is 20 squared. X squared is 20 squared minus 7 squared. It's 400 minus 49, which I guess is 351. So x is the positive square root of 351. So now I know how big x is. So this is what I called x. For now I'm done. Because this long diagonal is 8 plus x. X is square root of 351. And this other diagonal was given as 14 centimeters. So the area is 14, one diagonal, times the other diagonal over 2. And this is 14 centimeters, and this is 8 plus square root of 351 centimeters. When you multiply them, get centimeters squared. And 2 goes into 14 7 times. So it's 7 times 8 plus the square root of 351 centimeters squared. Now, just notice something. 9 goes into the square root of 351. And I know the square root of 9. How did I know that 9 goes into 351? Because when I add up the digits, 3 plus 5 plus 1, if 9 goes into that sum, and 9 does go into the sum is 9. 9 goes into 9. Then 9 goes into this number. 9 times 4, 9 times 3 is 27. From 35 leaves 8. And 9 into 81 goes 9 times. So now I know 351 is 9 times 39. And I know the square root of 39. But 39 just breaks down to 3 times 13. There's no perfect squares there. So what I know is the square root of 351 is the square root of 9 times the square root of 39. And I know the square root of 9. And I don't know the square root of 39, nor can I break it up. So this is the answer that most probably your teacher would want. That's the area of that kite. And I wasn't given the diagonals. Maybe I was given one of them. But I was given enough information to find the diagonals. If I didn't mark it on the last one that those two sides are equal and that these two sides are equal, well then, to be honest, you really can't talk about a kite. Okay. Suppose you have 10, 17, and you have 8. Okay, one of those sides shouldn't be there. I'm going to clear how that happened. Suppose that just that is 8. Okay. Well, of course, due to symmetry, that's also 8. So the area is going to be 16, one diagonal, not plus, sorry, 16 times the other diagonal over 2. I'm just waiting for the length of the other diagonal. Let us call this triangle 1, and let us call this triangle 2. If I find this length, and I find that length, I add them up, and I have the big diagonal. Well, in triangle 1, we have 8 and 10. Well, divide this by 2, you get 4. Divide this by 2, you get 5. It's a right triangle. In fact, with the smaller numbers, it's a 3, 4, 5 right triangle. Make sure the hypotenuse is the longest. In other words, if you had 4 and 3, right triangle, you can call that 5. Because the longest side should be 5. The hypotenuse should be the longest side. Okay, well, if you double these numbers, you get the real numbers. In this case, 6. 4, 6, 8, 10. 6, 8, 10. This here is 6. Okay, now let's go on to triangle number 2. Right triangle number 2. This is 8. This is 17. 17 squared is 170, 289. And 8 squared, 64. If you subtract this squared minus this squared, should be that one squared. That is, it should be 225, which is 15 squared. And as a geometry student, you should remember 8, 15, 17. So now we know that this is 15. 6 plus 15, 21. That gives me the whole diagonal. 2 goes into 16 8 times. 8 times 20 is 160. 8 times 1 is 8. 168, whatever the units are, squared. So, sometimes you're given the diagonals, the lengths of both diagonals. Other times, you're given enough information where Pythagoras can help you get the two diagonals. And then you multiply the two diagonals and divide by 2. Let's try one more. Suppose you have this kite, and 14 is the whole length, and this is a 15. And so let's make it 25. That's 25. So, I want the whole area. I know a little bit. I know one of the diagonals. So then I draw this line. Then I draw this line. In fact, this is a rhombus. All 4 sides are the same. A rhombus is just a special kite. Okay. So now I need to find out the diagonals. Now, it's not reasonable to assume that they're equal. Okay, the diagonal that's unknown right now seems to be longer. Okay. But those two will actually be the same length. AB cut diagonal CD or bisected diagonal BC. Okay, so basically, let's look at this triangle here. So right triangle, this is 25 and that's 7. Okay, and we'll call this x. So 25 squared minus 7 squared is x squared. 625 minus 49 is x squared. That is 576 is x squared. And maybe that's 28 squared. Well, that makes no sense. It can't be 28 because it has to be less than 25. Let's try 24. 4 times 24 is 96, and 2 times 24 is 48, and when you add those up, you actually get 576. So x is 24. So the other diagonal, 24 is that. The other diagonal is 24. Because when it comes to a rhombus, the diagonals bisect one another. So it is 48. When you split it in half, you get 24. 48 over 2 is 24. Okay. 24 times 10 is 240. And 24 times 4 is 96. And when you add these up, you get 336 square units. So know how to play the game. Know that a rhombus, all four sides are equal. It is a special kite. And what we know about the diagonals is they're not the same length, but they bisect one another. That completes this section.